The eye is a relatively simple optical instrument. On average, the adult human eye is a sphere roughly 24 millimeters in diameter. When light enters the eye, it is refracted by the cornea. This is a thin, transparent layer which acts as a positive lens with a fixed optical power. It is 12 millimeters in diameter and 0.5 millimeters in thickness, with an anterior radius of curvature of 7.8 millimeters and a posterior radius of curvature of 6.5 millimeters. Its refractive index is 1.38. After being refracted by the cornea, the light travels through the anterior chamber through a fluid called aqueous humor before it reaches the iris. The iris is connected to muscles which expand and contract to control the aperture size of the eye. This aperture is also known as the pupil. In bright light, the iris will contract to limit the rays entering through the pupil. In darker settings, the iris relaxes to let in more light. The aperture size of the eye ranges from 2 millimeters to 8 millimeters in diameter. The light let in through this aperture then passes through the crystalline lens. The crystalline lens is made of transparent tissue and can change shape to help the eye focus on objects at varying distances. It is an active optical element because, by changing shape, the lens has the ability to change the optical power of the whole eye. The layered structure of the lens means its refractive index changes throughout, increasing towards its center. Its equivalent refractive index is 1.42. The crystalline lens is biconvex with an anterior curvature of 10.2 millimeters and a posterior curvature of 6 millimeters. After being refracted by the lens, light passes through the posterior chamber. This chamber contains a transparent fluid called vitreous humor. Finally, the focused light is incident on the retina at the back of the eye. The retina uses photoreceptors to translate the upside-down image into electrical signals, which are then interpreted by the brain. The image quality produced by the eye is subject to imperfections. Since the eye is not a perfect shape, it is not a centered optical system, meaning that the optical centers of its components do not lie on a straight line. Even good eyes are not free of optical error since the retinal image of a point source is an extended distribution of light due to high-order optical aberrations. These optical aberrations are caused by the difference between the perfect and real wavefronts over the pupil. Optical aberrations are more noticeable with larger pupils, whereas image blurring due to diffraction is noticeable with small pupils. This is the setup I use to model the optical system of the eye. A glass sphere represents the posterior chamber, a magnifying glass works as the iris and lens, and an earbud tip acts as the pupil. Here you can see the result of my optical system where an image of an eye exam chart is placed in front of it. The image forms upside down at the back of the sphere like it does on the retina. Optical aberrations can be seen around the edge of the pupil in the form of blurring and discoloration. That concludes my presentation.